Okay, in this example we're going to find all the real zeros of this polynomial 3x to the fourth minus 8x cubed minus 37x squared plus 2x plus 40. And again, the way we go about doing this, at least the way I'm going to tackle the problem, is first off I'm going to list all the possible rational zeros. And okay, so to find the possible rational zeros, we look at all the factors of our constant of 40. 40's got quite a few factors. I think 1, 2, 4, 5, 8, 10, 20, and 40. Those are all factors of 40. Then we look at factors of the leading coefficient, which is 3. So the factors there would just be 1 and 3. And then it says all the possible rational zeros. We get positive and negative all the numbers that I'm about to write. So 1 over 1, 1 over 3, 2 over 1, 2 thirds. We could have 4 and 4 thirds. We could have 5, 5 thirds. We could use 8 or 8 thirds, 10, 10 thirds. Let's see, 20, 20 over 3. We could have 40 or 40 thirds. Any of those numbers could be possible rational zeros. So what I'm going to do now is use the remainder theorem, because again, if we plug one of these numbers in and get 0 out, that means it's a factor. So I'm just going to start off with the easiest one, and I'm going to plug 1 in. So if we plug 1 in, we'll get 3. You know, if you plug 1 in anywhere for the x, we'll just get 1. So we'll have 3 minus 8 minus 37 plus 2 plus 40. Well, 3 minus 8 is negative 5. Negative 5 minus 37 would be negative 42. Positive 2 and positive 40 would be positive 42. So hey, we get 0 out. So again, this tells us that x minus 1 is a factor. And I'm going to factor my polynomial now using long division. Or not long division, we could do long division. Let's use synthetic division. I think that's a bit easier. So again, synthetic division, we just write down the coefficients. So we've got a positive 3, a negative 8, a negative 37, a positive 2, and a positive 40. We said x minus 1 is a factor. So we just put a positive 1 outside. Again, that was our 0. And then we just drop down the first number. So 1 times 3 is 3, and then we just add. So we'll get negative 5, then we multiply. So negative 37 and negative 5 is negative 42. Again, we just drop that one over. If we add, we'll get negative 40. 1 times negative 40 is negative 40. We get 0 as our remainder, which we should be getting if 1 is in fact a 0. We started with something x to the fourth, so this will be 3x cubed. This will be our x squared term, our x term, and our constant. So it says our original polynomial f of x, 3x to the fourth minus 8x cubed minus 37x squared plus 2x plus 40. It says we can really write our original polynomial as x minus 1, that was our 0, so we knew that was a factor, times 3x cubed minus 5x squared minus 42x minus 40. Okay, so now what I'm going to do is I'm going to try to break down this factor, this 3x cubed factor, minus 5x squared minus 42x minus 40. I'm going to try to break that one down a little bit more. So again, we've got all these sort of possible rational zeros. So what we need to do is just simply find another one that's going to work. So maybe we'll call this function g of x, just because it's something a little different. So g of x is 3x cubed minus 5x squared minus 42x minus 40. So again, we've got a bunch of different candidates here. We've got all these numbers that we were just sort of testing out here. And what I'm going to do is, again, I'm just going to kind of trial and error, maybe plug in a couple different numbers. Again, which one should you use? That's where it gets a little tricky. We could use -1, but I think if we use -1, I don't think that's going to work at all. I'm going to jump over to use the next easiest number that I think, which will either be positive 2 or negative 2. So let's see, if we plug 2 in, we would get 3 times 2 cubed minus 5 times 2 squared minus 42 times 2 minus 40. So 2 cubed is 8 times 3 is 24. 2 squared is 4 times negative 5 will give us negative 20. Negative 42 and 2 will be negative 84 minus 40. Well, there's definitely lots of negative numbers out there. That's not going to equal 0. So that means x minus 2, that's not our factor. Maybe we can check negative 2. So if I plug negative 2 in, we'll get 3 times negative 2 cubed minus 5 times negative 2 squared minus 42 times negative 2 minus 40. Negative 2 cubes, negative 8 times 3 would be negative 24. Negative 2 squared is 4 times negative 5 would be negative 20. Let's see. Negative 42 and negative 2 will be positive 84. And then we've got our minus 40 left over. Hey, I think this one's going to work. Say if we get negative 24 minus 20, that's negative 44. Minus another 40 will be negative 84. So we have 84 minus 84. That gives us 0. That means negative 2 is a 0. And that tells us that x plus 2 is a factor. Okay, great. So we know the quantity x plus 2 is a factor. So what I'm going to do now is I'm going to do synthetic division on my factor g of x to sort of help us break it down a little bit further. Okay, so I'm going to take the coefficients. We've got 3, negative 5, negative 42, and negative 40. Again, our 0 was negative 2, so that's what goes on the outside. Let's be careful with our arithmetic, so we just drop down the 3. Negative 2 and 3 is negative 6. If we add, we get negative 11. Negative 2 and negative 11 is positive 22. Again, if we add, we get, what is that, negative 20. And negative 2 times negative 20 is positive 40. If we add, we get our remainder of 0, just like we should get. So again, we started with something x cubed. This will be our x squared term. This will be our x term and our constant. So what it says is, we were trying to factor f of x again, remember. So f of x was x minus 1 times this polynomial g of x. But again, we said a factor of g of x was going to be x plus 2. So I'm going to drop in my x plus 2. And then what would be left over would be our 3x squared minus 11x minus 20. Okay, so we could do two things. Again, we're trying to find zeros. To find the zeros of this quadratic factor, we could always just use the quadratic formula. I'm going to see if I can't play with numbers here and get it to factor. So to get my 3x squared, I'm going to need basically a 3x and an x if I use whole numbers. Let's see, what would be some good numbers that might work here? Let's see, what if we use 4 here and 5 there, because that'll give me 15 when I multiply. I think we can stick a negative there and a positive there, so let's check. We would get 3x squared minus 15x plus 4x, which would be negative 11x, and then we would get our negative 20. So it looks like to me this 3x plus 4 times x minus 5 is a correct factorization of our quadratic factor. And hallelujah, we have now got it factored. So if we want to find the zeros, again, we just set this whole polynomial equal to 0. So x minus 1 times x plus 2 times 3x plus 4 times x minus 5 equals 0. And then if we set each factor equal to 0, well, if we set x minus 1 equal to 0, we'll add and get x equals 1. Since x plus 2 was a factor, we said that that means that negative 2 is a 0. If we take 3x plus 4 and set that equal to 0, we would subtract the 4 and divide by 3. That would give me another 0. And then if we take our x minus 5 factor and set it equal to 0, we'll just get x equals positive 5 as our other factor. So pretty long-winded problems. You know, and again, finding zeros of polynomials isn't necessarily you know, a trivial endeavor. There's a lot of work that goes into it to hopefully get you to the right place.